Good morning, children. I hope all of you are fine and taking good care of yourselves. We will continue with construction of tangents to a circle. We will see all types of questions which are based on construction of tangents to a circle. They are number 1, using the center of the circle, we have to draw a tangent. Number 2, without using the center of the circle, we have to draw a tangent. And number 3, from a point outside the circle. So we have to draw tangents to a circle from a point which is lying outside the circle, which is the third one. So let us see one by one all types of questions. This is the first question. Construction of tangent to a circle using the center of the circle. Question. Draw a circle of radius 3.5 centimeter. Draw a tangent to the circle at any point on it. Now here, as I said before, there are three types. First is using the center of the circle. Second is without using the center of the circle. Now this question is not specifying. So it is completely on you whether you want to use the center or you don't want to use the center of the circle. Okay. I will be showing it using the center of the circle. So first and foremost, we have to take radius 3.5 centimeter. This is 3.5 centimeter. So let us take a center O, and using the measurement of 3.5 centimeter, let us draw a circle. So this is a circle with center O and radius 3.5 centimeter. So let us draw radius 3.5 centimeter. Okay, now I'm going to show this using the center of the circle. For this, we have to use the tangent theorem. The tangent theorem says that a tangent at any point of a circle is perpendicular to the radius at the point of contact. Remember this one. Correct? We'll be using this concept, right? The tangent is perpendicular to the radius. So let us see how to draw this. First and foremost, we have to draw a line from the center. A line from the center. Okay. Now I want a 90 degree at this point. At this point, I want a 90 degree. Why? Because as per the tangent theorem, the radius will be perpendicular to the tangent. So when I draw a 90 degree, I will get the perpendicular. So how to draw the 90 degree? This is the point of contact. I have to draw perpendicular from this point. So make a cut on the left and on the right. How to draw perpendicular? We have done this before. Again, from each of this, you have to make a cut above and below. And without changing the measurement from the other point also, you can make a cut above and below. Now just join them. It has to pass through this point. When you join these two cuts, it has to pass through this point. So this is your tangent, which is perpendicular. Okay. Now in the question, suppose it is given, take a point M on the circle and draw a tangent, then this will be your point M. In this, nothing is given, so I'm just naming it just like that. But if it is given in the question, you have to name this as that point which is lying on the circle through which you have to draw the tangent. So this is the tangent. This is the first method of construction of tangent to a circle, which is using the center of the circle. Now let us see the next construction, which is without using the center of the circle. Construction of tangent to a circle without using the center of the circle. Draw a circle of radius 3.5 centimeter. Draw a tangent to the circle at any point on it without using the center. So again, first and foremost, we have to draw a circle of radius 3.5. So let us first take 3.5. This is 3.5. Take any point, say O as the center, and draw the circle. This is the circle. Okay. Now, without using the center means you have to use this concept, the tangent secant theorem. This concept you have to use. The tangent secant theorem, which says that the angle between the tangent of a circle and a chord, okay, The angle between a tangent of a circle and a chord drawn from the point of contact is congruent to the angle inscribed in the arc opposite to the arc intercepted by that angle. So here this is the tangent. This is the chord. This is the angle between the tangent and the chord. Right? The angle between the tangent of a circle and a chord. This is the angle, this angle. Okay. Now, which is the arc intercepted by this angle? It is this one. This is the arc intercepted by the angle between tangent and chord. Right? This is the arc. This arc. Okay. Now, the arc opposite to this one is this one. This is the opposite arc. Okay. The angle inscribed in the opposite arc is this one. This is the angle inscribed in the opposite arc. Correct? Now, this theorem says that these two angles are congruent. They are congruent. That means angle YXQ, the angle between the tangent and the chord, YXQ, is congruent to YZX. That is the angle which is inscribed in the opposite arc. This point Z can be anywhere. Can be anywhere in this arc. Okay, so whatever is the angle formed by YZX will be equal to the angle formed between the chord and the tangent, which is YXQ. So this is the concept which we are going to use. So first and foremost, we will draw a chord anywhere. Let us draw a chord, something like this. Let us name it as AB. Okay. Now we have to inscribe an angle in this opposite arc. So take any point anywhere. Say suppose this is C. So let us join A, C, B. Right. So this is the angle which is formed in the arc which is opposite to this arc. Correct? This is the arc. ACB is the arc which is opposite to this arc. What we are planning is to draw a tangent here. So if we draw a tangent here, this angle should be equal to the angle formed between the chord AB and the tangent. So what we are going to do is we are going to draw congruent angles. We know how to draw congruent angles. So first and foremost, let us draw congruent angle from point C. So this is one cut from point C. From point B also I want to make equal angle. So without changing, you will make a cut at point B also. Let us see how much this arc is opening. It is opening this much. It is opening this much. So same measurement, you have to make a cut from this point where the arc is intersecting the chord to other end of the arc. So this is the point. So now simply you have to join this point of contact to this point B. So when you join, you get the tangent. You get a tangent, suppose PQ. Okay. So this angle ABQ is congruent to angle ACB. Okay, by tangent secant theorem. So this is how you draw the tangent to a circle without using the center of the circle. Let us see the third method of construction of tangent to a circle from a point outside the circle. So question is, draw a circle of radius 3.5 centimeter Take point X at a distance of 8 centimeter from the center. Construct tangents to the circle from point X. So first and foremost, let us take radius 3.5 centimeter. This is 3.5 centimeter. Now taking anywhere a point O, draw the circle. That's the center, so draw the circle using this center. This is the circle with center O and radius 3.5 centimeter. So this is radius 3.5 centimeter. We have to draw tangents from a point X at a distance of 8 centimeter from the center. So let us draw a segment which is 8 centimeter from the center. So from this point till 8. This is your point X. This is the point X which is at a distance of 8 centimeter from the center. Now I will construct the tangents first and then I will explain the concept behind it. Okay. So after you draw the segment, you have to find the midpoint of this segment. How to find the midpoint of this segment? By drawing the perpendicular bisector of segment OX. So let us take more than half of OX and make a cut above and below. Without changing, from point O also make a cut above and below. So join these two cuts and you will get the center of this segment OX. So this is, say, point P. This is perpendicular and it's a bisector. Right? Now, taking this as the center of the circle and OP as the radius, you have to draw a circle. So taking P as the center and OP as the radius, let us draw a circle. Okay, so this is the second circle. Now the concept which is being applied here is, this will be the point of contact of one of the tangents and this will be the point of contact of other tangent, right? So X has to join this point. This will be your first tangent and X has to be joined to this point, which will be your second tangent. Now the concept behind it is this corollary. Angle inscribed in a semicircle is a right angle. Angle inscribed in a semicircle is a right angle. Consider this circle. This circle. In this circle, P is the center and OX is the diameter. So this is a semicircle. In a semicircle, if you take any point and you join it to one of the ends, this will be a 90 degree. So this is angle inscribed in a semicircle is a right angle, right? Now that, keeping that aside, let us see this circle. In this circle, the radius is perpendicular to this line, which is touching the circle at one and only one point. That means this is the radius and this is the tangent. Why? By the tangent theorem. A tangent is perpendicular to the radius at the point of contact. So this is the radius. This is a line which is touching the circle at one and only one point, and this is a 90 degree. So this is a tangent. So if I name it as L and M, then XL and XM are the tangents which are drawn from a point which is lying outside the circle. So this is the third type of construction of tangent to a circle. Thank you, children.